So in this video, let us look at a very important type of question, which is A cos x plus B sin x type questions. For example, assume that you're given this question. You're asked to solve 3 cos x plus 4 sin x is equal to 2. So how do we solve this? So we've already seen what we do with the expression A cos x plus B sin x. We can convert this expression into a single trigonometric ratio by multiplying and dividing with root of a square plus b square. So what we do is we consider a right angle triangle whose sides are 3 and 4. Whose sides are 3 and 4. Once you draw this triangle, you can always complete the hypotenuse. And whatever angle is here, let us call that angle as alpha. Let's call this angle as alpha. This alpha is a fixed angle because this is an angle whose tan is 3/4. Now, if 3 and 4 are the sides, obviously the hypotenuse will be 5 units, right? So what I do is I'll divide both sides with a number 5. So 3 cos x plus 4 sin x by 5 is equal to 2 by 5, right? 3 cos x plus 4 sin x by 5 is equal to 2 by 5. Now, what can 3 by 5 be written as? Because this by 5 is for both of these expressions. 3 by 5 can be written as cos alpha, right? So I can write this expression as cos alpha times cos x plus 4 by 5 can be written as, 3 by 5 can be written as sin alpha, right? So sin alpha times cos x, and 4 by 5 can be written as cos alpha times sin x is equal to 2 by 5. This implies, as you can see, this is of the form sin A cos B plus cos A sin B. This can be written as sin of A plus B sin of x plus alpha is equal to 2 by 5. Now what I do is I'll draw another triangle, other right angle triangle, whose one of the right angle side is 2 and the hypotenuse is equal to 5 this time. So let this be 2 and let this be 5. I can always draw a right angle triangle with these properties. Let the angle that is formed here be equal to beta. So we don't know this angle right now, but we can refer to the tables and get this angle. This is an angle whose sine is 2 by 5. This is an angle whose sine is 2 by 5. So 2 by 5 can be written as sine of beta. This implies sine of something is equal to sine of something. So x plus alpha is equal to n pi plus minus 1 whole power n times beta. And this finally implies x is equal to n pi plus minus 1 whole power n times beta minus alpha. So this will be the required solution to this equation. So I hope you can follow what we are doing. So these numbers are not standard numbers. So the angles that correspond to these numbers are not known to us. So what we do is we assume them as some alpha and beta. And if it's required, we can refer to these angles from the trigonometric tables. So first I draw a triangle with sides as the numbers given here. So I get an angle alpha. So I can convert this into a single trigonometric ratio. And similarly, you can draw a right angle triangle with these two numbers and you get a trigonometric ratio. Once you equate them, you get the answer. It's not necessary that I always convert this into sine. I can also convert this into cos. So for example, if I draw a triangle whose this side is 4 and this side is 3 and this side will be equal to 5, and I consider this angle as some angle delta. Let's call this an angle. Let us call this angle delta. Now 3 by 5 can be written as cos delta, 4 by 5 can be written as sin delta. So this equation becomes cos delta cos x plus sin delta sin x is equal to 2 by 5. So this is cos of A minus B, x minus delta is equal to 2 by 5. Now I'll draw a triangle whose this side is 2 and this side is 5. I'll consider this as gamma. So gamma is an angle whose cos is 2 by 5. So 2 by 5 can be written as cos gamma. So x minus delta is equal to 2n pi plus r minus gamma, x is equal to 2n pi plus r minus gamma plus delta. So this can also be done. So these two solutions refer to exactly same values, but these two look different. But once you expand both of them into roster form, you get the same answers from these two set builder forms. So I hope you have understood how we do the questions of the type a cos x plus b sin x is equal to some number. So let us look at this question. In this question, you asked to find the values of c for which the equation 3 sin x plus 4 cos x is equal to c has exactly one principal solution, exactly two principal solutions, no principal solution. So how do we do this? We do the same process as we have done before. So what I first do is I'll try to convert this side into a single trigonometric ratio. So 3 sin x plus 4 cos x by 5 is equal to c by 5. So this implies, so if I draw a triangle whose right angled sides are 3 and 4, the hypotenuse automatically becomes 5. Whatever angle is formed here, I call it alpha. So 3 by 5 can be written as sine alpha. 3 by 5 can be written as sine alpha sine x plus 4 by 5 can be written as cos alpha cos x is equal to c by 5. So this implies this is nothing but sine of x plus alpha is equal to c by 5. So now this equation has become a standard simple equation. Sine of something is equal to c by 5. So this equation usually have two principal solutions, or one principal solution, or no principal solutions. So when will this have no principal solutions? If it have no principal solutions, that means the c by 5 has to be lying outside the range of this side, because sine is always less than or equal to 1 and greater than or equal to minus 1. So sine always lies between minus 1 and plus 1. But if this number is more than 1, so you won't have a solution. So this equation does not have principal solutions if c by 5 is greater than 1 or less than minus 1. That means c is either greater than 5 or less than minus 5. In these two cases, you have no principal solutions. Next, if this has to have only one principal solution, exactly one principal solution. So we have already seen that sin x is equal to plus 1 and sin x is equal to minus 1 has only one principal solution. For all other values, you have two principal solutions. So sin x, if it is equal to 1 or minus 1, the maximum and minimum values, you have only one principal solution. That is pi by 2 and 3 pi by 2. You won't have allied positions for that. So one principal solution if c by 5 is equal to plus r minus 1, that is c is equal to plus r minus 5. And for all the remaining values which are okay, the equation sine of something is equal to something has two principal solutions. That means if c by 5 lies between minus 1 and plus 1, that is c lies between minus 5 and plus 5, you'll have two principal solutions. Two principal solutions. So these are the three cases that you encounter for equations like this. Thank you.